Namaste, welcome to Pythagoras Academy. In this video, we'll try to understand how to work on an ATWOOD machine which is placed inside an elevator. If it is a simple ATWOOD machine, then finding out the acceleration of the blocks or tension in the string is pretty simple. But now, if this ATWOOD machine is placed inside an elevator and it is suspended to a spring balance, and elevator is accelerating up with an acceleration a, we are supposed to find, suppose the question is to find the readings of the spring balance. Then this is quite challenging. The complexity has increased, but there is a simple way to approach this problem. If we work from elevator frame of reference, then it becomes a simple ATWOOD machine and it is easy to work on this. So from elevator frame, so what we'll do is we'll work from elevator frame of reference. From elevator frame, I am drawing the free body diagram of M1 as well as M2. Now on M1 there is force M1G and tension T. On M2 there is force M2G and there is T. Is that all? No, because we are working from elevator frame which has acceleration, so it is non-inertial. We should not forget pseudo force. The frame of reference is moving with an acceleration a upwards, so the direction of pseudo force will be downwards on both M1 and M2. So direction of pseudo force is downwards. So let me represent pseudo force with a different color. So pseudo force is down, opposite to the direction of acceleration of frame of reference, and magnitude is mass of the system into acceleration of frame of reference. Similarly here, direction is opposite to the direction of acceleration of frame of reference, magnitude is mass of the system, which is M2, and acceleration of frame of reference, that is A. Now as you see from the elevator, M1 and M2 are not at rest, they are accelerating. They have the acceleration with respect to the elevator and with respect to ground also. Now if the acceleration of M1 is A1 up, where A1 is acceleration of M1 with respect to elevator, then by constraint equations we can understand that acceleration of M2 by constraint motion, because motion of M1 and M2 is constrained by each other because they are connected with a string. If M1 is accelerating with an acceleration A1 up, then M2 will have acceleration A1 down as seen from the elevator. Now just apply Newton's second law. So the equation would be T minus M1G minus M1A. This is the net force which is equal to M1A1. Don't get confused between A and A1. A is acceleration of the lift or elevator, whereas A1 is acceleration of the blocks as seen from the elevator. Now this is the first equation, and second equation would be M2G plus M2A minus T, that is equal to M2A1. This is second equation. Adding up these both, we get rid of T, and it is M2 into G plus A minus M1 into G plus A, that is equal to M1 plus M2 into A. So this is the acceleration. So acceleration of the blocks with respect to the elevator, that is A1 is equal to M2 minus M1 into G plus A by M1 plus M2. Of course, for this question we don't need acceleration, we basically need tension, because look at this pulley. For this pulley there is T down and there is T down, and Kx is upwards, and because mass of the pulley is negligible, it is at rest, so the pseudo force on the pulley is also negligible, because the magnitude of pseudo force is mass of the system into acceleration of frame of reference. Because it is a light pulley, So we are dealing with light pulleys now in this particular segment. So it is a light pulley, massless pulley and frictionless pulley. So there is no need of, there is no pseudo force on it, net force is 0. So I can say that Kx, the spring force acting on this pulley, that is equal to 2T. The reading of the spring balance is nothing but twice the tension of the string. So in this question, it is indirectly asked to find the tension. So if you know the tension, the reading of the spring balance is simply twice the tension. So we got acceleration. If we get acceleration, we can find tension from equation 1. From equation 1, tension is m1a1 plus m1 into g plus a. So I'll write m1 into m2 minus m1 into g plus a. I'm substituting the value of a1 that we just derived plus m1 into g plus a. So it is, if I take m1 into g plus a common, so I am left out with m2 minus m1 by m1 plus m2 plus m1. So this is m1 into g plus a by m1 plus m2 is the LCM, and I have m2 minus m1. So there is no m1 here, it is 1. So it is m1 plus m2. So you can get rid of m1. So you have 2 m2 here. So finally the tension is 2 m1 m2 into g plus a by m1 plus m2. Now comes the final step, that is reading of the spring balance. Reading of the spring balance, which is nothing but Kx, that is equal to 2 times tension, which is 4 m1 m2 into g plus a by m1 plus m2. Of course, from equation 1 and 2, we can directly eliminate a1 and find tension directly. That would save some time. The reason why I derived acceleration is to tell you how to derive the relative acceleration. Okay, so if it is only to find the reading of the spring balance, we don't have to find a1. We can directly eliminate a1 and first find tension. So however, the reading of the spring balance is 4 times m1 m2 into g plus a by m1 plus m2. Yeah. So this is how you deal with ATWOOD machine which is placed inside an elevator. Isn't it so simple? When you deal it from elevator frame of reference, all you should know is how to properly apply the concept of pseudo force and deal with non-inertial frame of reference. Hope you understood it. Thank you so much.